Dear students, I hope you all must be fine by the grace of Almighty Allah. Here in today's lecture, I am going to discuss more about modern periodic table. As in the previous lecture, we have started this very topic, that's modern periodic table. In the previous lecture, I have discussed that this modern periodic law, it is based on the atomic numbers of the elements. So according to the modern periodic law, the properties of elements or a periodic functions of their atomic numbers. I have already discussed this law in the previous lecture with you people. So we were discussing some characteristics of this modern periodic law in the previous lecture, and I had given you the detailed information that this modern periodic table, it was prepared by Niels Bohr, and this law was given by Henry Moseley. So dear students, I have also talked about the periods, the horizontal rows in this modern periodic table. I have already discussed with you that in the modern periodic table or in the long form of the periodic table, there are 7 periods. So the elements in a period, they have consecutive, or we can say continuous atomic numbers. I have also already discussed that the first period contains only 2 elements. It's very short period. Second and third period contains 8 elements. It's called short period. And the fourth and fifth contains 18 elements. These are the long periods. While a sixth period contains 32 elements and it's very long period. And the seventh period that contains rest of the elements, which is incomplete. Dear students, in today's lecture, we are going to learn more about the characteristics of this modern periodic table. Now, let's go through the groups of the periodic. How many groups are there in the modern periodic table? Dear students, the vertical columns in a periodic table. You got it here. The vertical columns in a periodic table, they are termed as groups. Vertical columns. Vertical column means just like this. Vertical. Okay, so these are horizontal columns, or we can say the vertical columns in a periodic table, they are termed here as groups. Dear students, there are 18 groups. There are 18 groups in the long form of periodic table. Here I have represented periodic table by pt here, that means periodic table. So there are 18 groups. You have to remember, you have to get clear that you have to get clear with this point that there are 18 groups in the long form of periodic table. So how many groups? 18 groups in the long form of periodic table. And how many periods? 7 periods in the long form of periodic table. Dear students, group first, the group first, we can say, it is on the left side of the periodic table. The group first of the elements is on the left side of the modern periodic table, while as the group 18, it is on the extreme right side of the modern periodic table, or extreme right side of the long form of periodic table. Got it here, dear students? And one more point which I would like to discuss with you is that, as I said, that there are consecutive atomic numbers in a periods between the elements, but the elements in a group, they don't have consecutive atomic numbers. So we can't have the consecutive, we can't have the continuous atomic numbers in a group. For example, if lithium is having atomic number 3, then the next element after lithium in a group is sodium. Sodium is having atomic number, suppose 11. So we can't have, or we can say, the elements in a group, they don't have consecutive or continuous atomic numbers. You have to remember. You have to get to know this point. Got it here, dear students? All elements in a group, they have same number of valence electrons. All elements in a group, they have same number of valence electrons. So if we start from lithium, beryllium, boron, suppose in the first very group, that's called alkali metal groups, they have same number of valence electrons. All these elements, they contain, we can say, that they have same number of valence electrons. That means their low shell contains only one electron. So lithium contains one electron, and then after that is sodium, then potassium, then rubidium, then cesium, and phosphorus. Got it here? So all elements in a group, they have same number of valence electrons. Dear students, the groups 1 and 2 and 13 and 17, remember it. The groups 1 and 2, first and second group, and 13 to 17, they contain normal elements, and they are called representative elements. So which groups of elements are called representative elements? Group first and group 2, and from 13 to 17 groups, they contain normal elements, and these groups are called representative elements of the long form of the periodic table or modern periodic table. Got it here? Dear students, similarly, the groups 3 to 12 elements, the groups starting from group 3 to group 12, they are called transition elements. They are called transition elements, or sometimes they are called d block elements. Dear students, in these group of elements from 3 to 12, which are called transition elements or d block elements, the outer shells, dear students, the outer shells in these groups, the outer shells, or we can say the penultimate shells, lost but one shell, they are incomplete. They are incomplete in the process of being filled with the electrons. You have to remember here this very point. Dear students, then the elements with atomic numbers from 57 to 71. Then there are certain elements whose atomic number starts from 51 and ends with 71. They are called a lengthenide series. You have to remember it. You may be asked in objective type or MCQ type questions, or a very short answer type questions, that what are actinide series. So the elements in a periodic table with atomic numbers from 57 to 71, they are called lengthenide series. And similarly, and elements with atomic numbers from 89 to 113, they are called actinide series. So we have got lengthenide series as well as actinide series in the modern periodic table. Got it, dear students? Dear students, in modern periodic table, metals, they have been separated from non-metals by some elements called metalloids. So metals and non-metals are separated in a modern periodic table by some, we can say, some other elements which are termed as metalloids. So what are they termed as, dear students? They are termed here as metalloids. Dear students, these metalloids are placed diagonally in the periodic table. The properties of these metalloids, they are intermediate between those of metals and non-metals. So metals and non-metals are separated by some group of elements, or we can say by some elements which are placed diagonally in the modern periodic table. They are termed as metalloids, and the properties of these metalloids are intermediate between metals and non. That means they show metallic as well as non-metallic properties. Got it, dear students? Dear students, I would like to add here that hydrogen element that has been placed at the top of the group first, that has been placed at the top of the group first of the modern periodic table. But while discussing the alkali metals of group first, hydrogen is never included because many properties of hydrogen, they are different from alkali metals. So here the modern periodic table, I can say I have concluded this lecture about this modern periodic table and its characteristics. Now in the next lecture I am going to discuss, dear students, with you trends in the physical and chemical properties. Till then, Allah Hafiz.